All right, so we're going through some calculus stuff here, starting with tangents to a curve. So this is a classroom activity we did. The thick curve is a graph of y equals f of x. Here we are. And we're going to complete the following. F of 1 equals, now this is just finding the y value. So we're just getting that from the graph. So f of 1 equals negative 5. So that's like looking here at 1 comma negative 5. All right, quickly through the rest of them. F of 2 is 0. F of 3 is about 2.2 perhaps. F of 4, 2.3. F of 5, that's here, about 1.3. F of 6 is 0. F of 7 looks like about negative 0.75 perhaps. F of 8 is 0, and F of 9 is 3. Right, and we can fill in a table of values for that. So we've got negative 5, 0, 2.2, 2.3, 1.3, 0, negative 0.75, 0 and 3. Okay, so that's just reminding ourselves of notation. F of 1 is the y value when x is 1, for instance. All right, activity 2. The thin straight line above is the tangent to the curve. So this here is a tangent to the curve where at the point A, or the tangent where x equals 1. By looking at the graph, estimate the gradient of the tangent to the curve. So what's the gradient of this? Well, it's quite a steep line. What we can do is say, well, from here, I'm going to go across 1, right, across 1, and then I have to go up 1, 2, 3, 4, 5, 6 and a half units to get back on that line. So the gradient is about 6.5. Okay, so the curve itself doesn't have a gradient really because the gradient's always changing, but if you draw a tangent at a particular point, then and that tangent has a gradient of 6.5, that tells you, oh, the curve's really increasing very strongly at that point. But here, it's not increasing as strongly. Get the idea? Right, now here's a bit of notation. F-1 equals, 6.5, but really what we mean, F-1 means the gradient of the tangent drawn at the point where x equals 1. All right, so that's new notation. F-1 means the gradient of this tangent, right? And if I drew another tangent here, that would be like F-3.4 is the gradient of that tangent. Okay, so every x value can produce a tangent, and then we can get the gradient of it. Activity 3. With a ruler, draw the tangents at B and C. Estimate their gradients and complete the following. So I can't really use a ruler here, but I'm going to use a straight line and try to do right, I've done that pretty well. And here, if I just sort of move that up a bit, right? So the idea of a tangent, just imagine that this thing's like a solid object and I'm putting a ruler up against it. So I can't go through the curve. I have to press the ruler hard against the solid object and it's got to touch this point here. Right, so this one, because of the nature of the curve, it kind of has to slice through. Maybe I can do it a bit better. Like near enough, there we go, that's a bit better. Near enough is good enough. We're just trying to work it out. Right, so I'm going to do C first. So C, if you go across 1, then you go up, well, it looks like about 1.7. Okay, so the gradient of C, that's F-8, right? See, this is the value where x equals 8. So F of 8 is 0, that's where the point is. F-8 is approximately 1.7. That's the gradient of the tangent. Right? So this tells you where something is, and this tells you where it's going. It's going in that direction. And then at B, that's a negative gradient. So if I go across 1, and then I have to go down about 1.4 or something. So F dash 5 is about negative 1.4. Right, so here we go. That's negative 1.4, and that was, the other one was about 1.7. Now complete the table of values. So what we know so far is values for 1, 5 and 8. So we don't know any values for these. Well, how would we find values? We would draw more tangents and we would find more gradients. But we're not going to do that. 3 is enough. So I've got 6.5 and negative 1.4 and 1.7. My point here is that we can do a table of values where these are all gradients of tangents. So f dash x is a function, right? If you can put it into a table of values, then it's a function. And you want to know where the gradient, what the gradient of a certain tangent is, you plug it into this function and you find out. Now we don't know what the equation of that function is, but the point is it is a function. Right, activity 4. So we're going to graph this in GeoGebra or Desmos, and we're going to plot a point on the curve, create the tangent, and then look at the gradient of all of the tangents. So I've got that here, right? Damn it. Okay, so here's the curve, right? And I have created the point at where x equals 1. Now, interestingly, on here, the point is a little bit below negative 5. So I don't know why the difference here and on the sheet, but anyway, it doesn't matter. And now, if I move the 1, there we go, I just moved it to 2. We've got a new tangent. And if I move it to 3, a new one, and then 4, 5, 6, 7, 8, and 9. All right, so we're going to get the gradient of all of these tangents, but the equation of the line, I can't I can't laser point here, but you can see the last thing on the left-hand side says G is a tangent of A at F. So it's y equals 7.05. Actually, what I can do, I'm going to get the slope of this. There we go. That's better. All right. So now, as I go through, you need to write down the values. So f-1 is 7.05. We estimated it to be 6.5 before. Well, we were a bit wrong. When it's 2, 3.6. When it's at 3, 1.05. When it's at 4, negative 1.06. Sorry, negative 0.6. When it's at 5, there you go. Now I'm going to actually show all of the values soon. What I want you to notice here is just how the technology is showing us what the gradient of all these tangents is and how that's changing, right? And have a look there. There it's going up and there it's going down. So in between somewhere, it's going to have a gradient of 0. The tangent's going to be horizontal. Okay, so what are the values? I've got them here. So there we go. All right. There are the values. The values themselves aren't important. Just your understanding of what they represent is important. All right. Activity 5. Plot the values of f-x on the number plane. So we are basically, there are pairs here. I'm going to plot the point 1, 7.05. So that's roughly there, okay? And then 2, 3.6. Now you can just watch me do this if you like, or you can pause and plot the rest yourself, okay? It'll be a nice little aha moment if you do it yourself. So you can pause, I'm just going to go ahead. Right, 2, 3.6, I've done that one. 3, 1.05, 4, negative 0.6, 5, negative 1.35, 6, negative 1.2, 7, negative 0.15, 8 is 1.8, and 9 is 4.65. Now, isn't that interesting? These seem to form a parabola. Okay, so there you go. That's interesting, and I can actually do that on here. So what I'm going to do is change the y to be the a to go like step, say 0.1, and I want to plot the points that I just did. Well, the x value is a and the y value is m. So all I need to do is plot the point. So just go to input, put bracket a, m, enter. So it's plotted that point. And I'd like to maybe change the colour to that. And I'm going to turn a trace on. And now I'm going to vary A, or I'm just going to press play and A can vary itself. And you can see a lot of these points being plotted, and it really is tracing out a parabola. It's very nice. So have a think about this. The original curve is a cubic, and the gradient function is a parabola. All right, so I'm just going to pause here, and I just want you to notice when the red parabola is below the y-axis, that means that the gradient has a negative value. Look at the green cubic in those places. It has a negative value. But when the red parabola is above the x-axis, then that means the red parabola, the gradient function has a positive value, and the green cubic has a positive gradient in those locations. Right, so there's this relationship between the original curve and then the gradient of that curve. So the original was a cubic, and then the gradient function is a parabola. Its degree has gone down by 1. Right, that's significant. Okay, so we've done that, right? And then that's the end of this worksheet. And then I have a follow-up, which we did in the same lesson. So here's the correct table of values, here's the points and so on. And here's the thing that we now pay attention to. So just like f of x has an equation, so does the gradient function f dash x. That's a poorly written f dash x there, okay? The graph you studied had this equation, so it was a cubic with those factors, and you put in the 0.15 to scale the y-axis down a bit. There it is expanded. Now, the gradient function has this. Okay, now technology can tell me that. Now I want you to look at them carefully. So have a look here. I've got the original function in expanded form, and I've got the gradient function. Can you see any connection between them? You'd just like to pause the video and allow yourself 30 seconds. You should be able to see a lot of connection. Okay, so the easiest thing to see is this 11.4 stays, right? And this goes to nothing, and there's a reason for that. The 2.4 becomes 4.8. Well, that's 2.4 times 2 gives you 4.8. And the 0.15 goes to 0.45. Well, that's 0.15 times 3. Right, so what's happening is we multiply that by that to get that, and then it's x squared instead of x cubed. It goes down a degree. Right, this is that times that to get that, and then the x squared goes to x, it goes down a degree. There's a silent 1 here, x to the 1, so we've got 11.4 times 1 gives us 11.4, and then that goes down a degree, x to the 0, and then this goes down a degree, which means there's nothing there. Or you can think of it as that's x to the 0, so you've got 14.4 times 0 gives you 0, okay? Now, that's all of the connections that we need. Just like to comment, why does this disappear? Well, because if you have an original cubic curve, then it doesn't matter. If you change the constant at the end, all you're doing is moving the thing up or down. It doesn't change anything about the gradient at each x value. So that's why this has nothing to do, this doesn't have any influence on this. If we make up another function, say g of x equals 0.4 cubed, etc., can you work out what the gradient function g dash x will be? So you can pause and do it. Here we go. G dash x. So multiply the 0.4 by 3, I get 1.2, and I drop the degree, x squared. I multiply 5.3 by 2, so that's 10.6x, and then minus 23. Right? And the 8.7 has no impact. So that, the process that we do, when we start with g of x and we get to g dash x, that process is called differentiation, related to the word difference. That significance of the word difference might become apparent later on. Okay, so that's the end of this one. I'm going to end this video here and then start the next thing there.